An ellipse is the set of all points P in a plane such that the sum of the distances from P to two fixed points called the foci is constant. No matter where point P lies on the ellipse, the total length of the segments PF1 and PF2 always remains the same. Let's learn the names of the parts of an ellipse. The two fixed points are called the foci, and they always lie on the major axis, which is the longer line segment that runs through the widest part of the ellipse. Perpendicular to the major axis is the minor axis. The endpoints of the major axis are called the vertices, and the endpoints of the minor axis are called the covertices. The center of the ellipse is the point where the major and minor axes intersect. Now let's look at the equation of an ellipse. There are two forms of the standard equation, depending on which axis is the major axis. If the ellipse is wider than it is tall, that means the major axis is horizontal. Its equation is x squared over a squared plus y squared over b squared equals 1. In this case, a is the distance from the center to a vertex along the x-axis, and b is the distance from the center to a covertex along the y-axis. On the right, the ellipse is taller than it is wide. That means the major axis is vertical. Its equation is x squared over b squared plus y squared over a squared equals 1. Now, a is the distance from the center to a vertex along the y-axis, and b is the distance to a covertex along the x-axis. In both cases, the value of a always goes with the major axis, and the value of b goes with the minor axis. If the center of the ellipse is not at the origin, we adjust the equation to match its new location. We subtract x by h and y by k, where hk is the new center. The rest of the equation stays the same. In an ellipse, the total distance from any point on the ellipse to the two foci is always equal to the full length of the major axis, which is 2a. In this diagram, point P is at a covertex, and the two green segments from P to each focus add up to 2a. That means the distance from a covertex to one focus is exactly a. By connecting the covertex and the focus, we form a right triangle. In this triangle, the red side labeled A represents the distance from the covertex to the focus. The blue side B is the distance from the center to the covertex, half of the minor axis. And the purple side C is the distance from the center to the focus along the major axis. Since this is the right triangle, we can apply the Pythagorean theorem, where A is the hypotenuse and B and C are the two legs of the right triangle. So a squared equals b squared plus c squared. This equation shows how these three distances are related in every ellipse. It's especially useful when we know two of the values and want to find the third. The graph of the ellipse has vertices at 1, 3, and 1, negative 7, and covertices at 5, negative 2, and negative 3, negative 2. Write the equation of the ellipse. Start by plotting the two vertices, 1, 3 at the top, and 1, negative 7 at the bottom. Next, plot the covertices 5, negative 2 to the right and negative 3, negative 2 to the left. You should now see a tall vertical ellipse forming. Since it's a vertical ellipse and the center is not at the origin, the general form of the equation is x minus h squared over b squared plus y minus k squared over a squared equals 1. Let's draw the major axis and the minor axis to find the intersection, which is the center of the ellipse. We can see that the center is at 1, negative 2. Plug in 1 for h and negative 2 for k. To find b, find the distance from the center to a covertex. We get 4 for b. A is the distance from the center to a vertex, which is 5. Now simplify the equation. We get x minus 1 squared over 16 plus y plus 2 squared over 25 equals 1. Graph the ellipse that has the equation x squared over 100 plus y squared over 64 equals 1. What are the coordinates of the foci? The general form of an equation of a horizontal ellipse centered at the origin is x squared over a squared plus y squared over b squared equals 1. From the given equation, we can find a by setting a squared equal to 100. Since a is a distance, we take the positive root of 100, which is 10. Next, solve for b by setting b squared equal to 64. The positive root of 64 is 8. From the equation, we know that it's centered at the origin, and since the denominator under x is larger, it will be a horizontal ellipse. Let's sketch the ellipse. The foci lie on the major axis. To find the distance between the center to each focus, remember that A is also the distance between the covertex and a focus. We can use the Pythagorean theorem to set up an equation. C squared plus 8 squared equals 10 squared. We get C squared plus 64 equals 100. Isolate C by subtracting 64. Then take the square root of both sides, giving us C equals 6. Since the ellipse is horizontal and the center is at 0, 0, the foci are located 6 units left and right from the center. We can find the coordinates by subtracting or adding 6 to the x-coordinate of the origin. We get negative 6, 0 and 6, 0. The equation 2x squared minus 12x plus y squared minus 2y plus 15 equals 0 represents an ellipse. Graph the ellipse, identify the center, vertices, covertices, and foci. Our goal is to rewrite it in standard form so we can easily identify the center, vertices, covertices, and foci. First, group the x terms and the y terms together, and move the constant 15 to the other side to prepare for completing the square. Factor out the coefficient of the x squared term from the first group. Now complete the square in both groups. For the first group, half of negative 6 is negative 3, and negative 3 squared is positive 9. Add this inside the parentheses, and balance the equation by adding the same amount to the right-hand side. For the second group, half of negative 2 is negative 1, and squaring it gives us 1. So add 1 inside the parentheses and on the right-hand side. Now factor the perfect square trinomials. We get 2 times the quantity x minus 3 squared plus the quantity y minus 1 squared equals 4. Divide everything by 4 to get it in standard form and simplify. We get x minus 3 squared over 2 plus y minus 1 squared over 4 equals 1. Since the larger denominator is under the y term, it's going to be a vertical ellipse. Let's graph the ellipse by first finding the center. H and K are 3 and 1, so the center is at 3, 1. Let's solve for b by setting b squared equal to 2. b is equal to the square root of 2, which is about 1.4. This will be the horizontal radius. Solve for a by setting a squared equal to 4. a equals 2. And this is the vertical radius. To graph the ellipse, move 1.4 units horizontally and 2 units vertically from the center. The vertices are the endpoints of the major axis, which are at 3, 3, and 3, negative 1. The covertices are the endpoints of the minor axis, which are located at approximately 1.6, 1 and 4.4, 1. To write the exact location, we can subtract and add the square root of 2 from the x-coordinate of the center, giving us 3 minus the square root of 2, 1, and 3 plus the square root of 2, 1. To find the foci, remember that A is the hypotenuse of the right triangle. We know that B is the square root of 2, so we use the Pythagorean theorem to find the distance between center and a focus point. We get C equals the square root of 2. Since the major axis is vertical, we move the square root of 2 units up and down from the center, giving us foci at 3, 1 plus the square root of 2 and 3, 1 minus the square root of 2.